Hey guys, my name's Acer, and I'll be your host for this Godot 3 tutorial on ranged projectiles, specifically a single target arrow and an area of effect fireball. A link to download all the project files that I use in this demo can be found in the description. This tutorial is sponsored by our course Learn to Code from Zero with Godot, but more on that at the end of the video. I'll start by going over how to make an arrow that travels in a straight line and deals damage to the first enemy that's hit. Next, I'll show you how to make a player that can aim where the cursor is and shoot a projectile in that direction. After that, I'll show how to make an enemy that can get hit by the projectile. And finally, I'll show you how to make the fireball. It's very similar to the arrow, but when it hits an enemy, it deals damage to all nearby enemies. This video will not cover hit scan based weapons using raycasts. We'll cover that in a future video. Let's start with the arrow. I'm in the arrow scene, and you can see that it's made up of 4 nodes. The sprite, a hitbox, which is an area 2D, the impact detector, which is also an area 2D, and a timer. The sprite is obviously what the arrow looks like. I've added an arrow PNG to the sprite's texture by just dragging and dropping it like that. And I've also scaled it down by 50% just so it is the correct size. The hitbox's sole purpose is to be detected by the enemy. This specific hitbox is identical to the one that was taught in our How to Code Melee Attacks in Godot video. If you want to learn more about hitboxes and hurtboxes, or about melee attacks, I'd highly recommend checking it out. Our hitbox is an area 2D, and it has a collision shape 2D inside of it with a circle shape. The hitbox should be monitorable because the hurtbox detects it. But the hitbox isn't monitoring anything, so monitoring should be off. The collision layer should be set to 2, which is the layer I'm using for hitboxes. The mask should have nothing set, because the mask is what this area scans, but again, it's not scanning anything. And finally, the position, which is the location of the area, I put it right at the tip of the arrow. So that's the hitbox. It does have a script though, so let's take a quick look at it. Here's our script. It gives our hitbox a class name of hitbox. It exports a damage value that we can change in the inspector. We set our collision mask and collision layer here, although I've already done that. And it gives us an easy way to disable our collision shape 2D. The impact detector is very similar to the hitbox with a couple key differences. But first, why do we even need this impact detector? Well, we want our arrow to be destroyed on the first enemy it hits. If it doesn't, it'll look like this, and we really don't want that for this projectile. The problem is that the hitbox is only monitorable. It's not monitoring, so we don't actually know when it hits something. That's where the impact detector comes in. It's an area 2D with a collision shape identical to our hitbox. It's monitoring our game world layer, which is the same layer our enemies are going to be in. So this is what tells our arrow that it hit something. Again, it is really important that our hitbox and impact detector are exactly the same size and in the exact same position, because we want them to both activate at the same time. Now, yes, you definitely could do this with just one area, but again, it's good to keep things separate. And finally, the timer. We want our arrow to have a lifetime, because if it travels for too long without hitting something, we want to destroy it. We don't want it to just travel infinitely. So that's where the timer comes in. It's set programmatically, and when it hits 0, we destroy the arrow. Now let's look at the arrow's script. You'll see that we have all the functions commented out. We have a class name of projectile, 2 exported variables, speed and lifetime, and a direction variable. So the first thing we want to do is to fix that. In the ready function, we want to call set as top level. And what this does is make the arrow move independently of the parent. Now if we play, you'll see that it's spawning in where we want, and it's not connected to the player. Next, let's make the arrow face the correct direction when it's spawned in. We want it to face where we're aiming. We can do that with the lookat function. By calling the lookat function right when the arrow spawns in and passing in the position plus the direction we want it to turn towards, it looks like this, which is perfect. Now, you should be wondering, where is the direction variable set? Well, that's set in the player. Here's the line. We will go over it, but all you need to know right now is that it's a normalized vector that's pointing at the mouse position from the player's position. I think it's time to make the arrow move now. To do that, we change the arrow's position just a little bit every single frame, and we change it in the direction of, well, our direction. The physics process function is exactly what we need for this. It gets called 60 times a second, and we can use it to update our position. So we update the position each frame by the direction times the speed times delta. Delta is the amount of time in between frames, and we multiply by that, so regardless of someone's frame rate, the arrow will move at the same speed. Now if we play, you'll see that the arrow is moving in the direction we're aiming at a constant rate. Although there are two issues. The main one is that the arrow does not destroy itself after it hits an enemy. It just goes through all the enemies. And the other is that it's not destroying itself at the end of its lifetime. It lives forever. Let's start by making the arrow destroy itself when it hits an enemy. To do that, we need to connect to the impact detector's body entered signal. So the line is right here, impact detector.connect. Body entered is the name of the signal, self, and then on impact is the name of the function we want to be called when this signal is received. So here is that function, on impact, and all we do in it is queue-free. The reason we don't just put queue-free into here is because we may want to do other things on impact, not just free itself. Maybe, I don't know, play an effect, play a sound, something like that. Now when we play, the arrows are actually colliding with the enemy. And finally, let's make the arrow destroy itself at the end of its lifetime. For that, we'll need a timer, and we need to connect to the timer's timeout signal, and we do that with this line. So timer.connect, and then timeout is the signal, self, and then queue-free is what we call at when the signal gets emitted. If you didn't know, queue-free deletes the arrow at the end of the frame. And then finally, we need to start the timer with the time of the lifetime. All right, let's test this. I'm gonna set the arrow's lifetime to something shorter. How about 0.4, so we can actually see it die on screen. And if we shoot our arrow, look at that. After 0.4 seconds, it's destroyed. But then if we hit the enemy, it's destroyed when it hits the enemy. All right, with the arrow finished, let's take a look at the player. Normally, the player in a game is pretty complex, but in our case, it is very simple because it's just a wand that points where your mouse is. So all we need is a sprite and a shoot position, which is a position 2D node. In the player script, we do three main things. We make sure the wand is constantly looking at the mouse. We are reading the player's input, so left click and right click. And we're shooting the projectile, or rather we're spawning it in. It is super easy to make the wand look at the mouse. In the physics process function, I'm calling look at, and I'm passing in the position I want the wand to look at, which is get global mouse position. And that does exactly what you think it does. Now let's take a look at the shoot function. Its purpose is basically to spawn in the projectile in the right direction and at the right position. So it takes in a pack scene, for example, our arrow scene, and it creates an instance of it and sets that instance equal to the variable projectile instance. Next, we set the position of the instance equal to the shoot position's global position. Remember, our shoot position is our position 2D node right here. It's pretty cool. You can move the gizmo wherever, and then this is its position. We also set its direction. Now, position is like a built-in variable. It's its position. But direction, remember, was this variable right here. So we set the direction equal to global position, the global position of the player, dot direction to the global mouse position. Direction to, if we just control click, it returns the normalized vector pointing from this vector to B, this vector being the player's position. So again, it returns the vector from the player that points to the global mouse position, and then it's normalized, so the length is 1. And finally, we add the instance as a child to the player by calling add child and passing in the projectile instance. Now, how do we actually call that function, the shoot function? We do that by sensing the left and right click in the unhandled input function. This function basically is called whenever an input is made that isn't consumed by anything else. In this case, we are checking if that input is the left click, and if it is, we shoot the arrow scene. If it's the right click, we shoot the fireball scene. Now, these left click and right click events aren't actually built in, so let me show you how to add them. We go to Project, Project Settings, Input Map. And you see I have the right click and the left click. I'm going to delete the right click so I can show you how to re-add it. Type in the action name here, so right_click, and press Add. Now it'll scroll you all the way down, and we want to press this little plus button here, and then press mouse button. Find which mouse button you want, which is the right button, and then click Add. And now this event name, right click, is associated with the right click. So that's the player and the arrow, but what about the enemy? How do we make the enemy sense if the arrow hits it? So here's our enemy scene. The enemy needs to sense if an arrow hits it, and if it does, it plays a little animation. That's pretty much it. The root node for the enemy is actually a kinematic body 2D, and the main reason for that is so we can add a collision shape to it. The enemy is in the game world layer, and this allows the arrow's impact detector, which is scanning the game world layer, to detect the enemy. The enemy, of course, has a sprite, and it also has a hurt box. This hurt box is an area 2D, and it is monitoring the hitboxes layer. So it will be able to sense anything that is in the hitboxes layer. For example, the hitbox of our arrow. So let's take a quick look at its script. The main thing to note is the onAreaEntered function, which is called whenever anything enters its area, whenever it senses anything. It is specifically looking for a hitbox. And remember, we set our hitboxes class to hitbox. So it's not just sensing things that are in the layer of hitboxes, it also has to have the class name hitbox. So if it does sense a hitbox, an area 2D with the class name hitbox, and the owner has a method called takeDamage, it calls that method. And in this case, owner is the enemy. And it just so happens that the only function our enemy has is our takeDamage function. All our takeDamage function does is stops the animation player and then plays the animation player, the hit animation. And of course, the hit animation is the animation that plays when the enemy takes damage. Now, it's important to note the collision shape for the hurt box and the kinematic body should be exactly the same. And that's it for the enemy. One thing, though, you may have noticed that the damage value that we're dealing to the enemy isn't being used, but I promise you it's working. We can print that out and press play. And then, and then in the output below, you can see it's printing the amount of damage we're dealing. So now we have a player that aims towards your mouse, an arrow that shoots in the direction of the player, and enemies that get hit by that arrow. But what about an area of effect projectile? For example, this fireball, where when it hits an enemy, it deals damage to everything around it. Here's the fireball scene, and it is very similar to the arrow with a few differences, mainly in the script, but there are some differences with the nodes. The big one being the collision shape for the hitbox and the impact detector. They're not the same size. The hitbox is what deals the damage, and this needs to be big because we're sensing the enemies around the fireball. The impact detector's collision shape, on the other hand, should be really small because we're trying to detect when the actual fireball hits the enemy. The hitbox collision shape also is starting disabled. It starts disabled because if it didn't start disabled, it would just deal damage to the first enemy that entered the zone. I mean, I can show you what that looks like, which is really not what we want. We only want it to deal damage once the actual fireball hits an enemy. And of course, the sprite texture is different, and we have explosion particles. But what about the script? Did I rewrite everything from scratch? No, no, I did not. I extended the projectile script. What does this mean, though? Extends projectile. The way I look at it is if something extends another thing, it is that thing, and then everything else is in addition to it. So you could almost replace this with all of this code. Now, you can't literally do that, but that's basically what's happening. Now, if that's all you could do, that would be kind of weird. Another thing you can do is overwrite an existing function, a function that is coming from the class you're extending. In this case, we have onImpact, and in the base class, we're just immediately freeing. We're immediately deleting the projectile. But with the fireball, we want to do some stuff before we get rid of the projectile. So I overwrite it by writing the exact function name and then putting different stuff in it. So what is the stuff we're putting in this function? Well, first, we want to enable our hitbox. Remember, it started disabled because, again, we don't want the enemies to get hit by that big zone until the little fireball hits something. And next, we are almost immediately disabling it again. We create a timer for 0.1 seconds, and we connect to the timeout signal and call disable hitbox when that timeout signal emits, so after 0.1 seconds. And all disable hitbox does is disable the hitbox. So we're flickering on this hitbox. What else do we do? Well, we want to set the speed to 0. We want the fireball to stop moving after it hits something. We want to emit the particles, so start our particle effect. And our particles are one shot, so they will only play once. It's not going to loop. We want to make the fireball sprite invisible. It looked kind of weird if the fireball just sat there. And finally, this is a little bit tricky. We start the timer again. So remember, the timer's already starting, and it's ticking down based on the lifetime. I want to restart that timer and set it to 0.6 seconds. Why do I do that? Why don't I just destroy the projectile when the particle effect is done playing? The reason is because the lifetime timer that when it goes to 0 destroys the projectile will actually cut off the explosion effect if it finishes while the explosion effect is playing. So let me actually show you that. So instead of restarting this the lifetime timer, I am just creating another timer for 0.6 seconds, which is how long our explosion particles last, and Q freeing at the end of it. I've also set the fireball's lifetime to 0.55, and that's a very specific number because, well, you'll see. Notice how the explosion is getting cut off. We don't want that. So to prevent it, we restart the lifetime timer for the amount of time the explosion particles last. And now, even though the lifetime is still 0.55, the full explosion plays. That's it, we're done. Great job on making it this far. If you want a little bit of a challenge, try these couple of things. Try adding multi-shot. So right now we're shooting 1 per shot. Try 2 or 3. Try adding spread. So what do I mean by that? Right now we're shooting very, very accurately. We're dead straight like a laser. So instead, make it less accurate. Try adding some ammo. Right now we can shoot an infinite amount of times. Make it so maybe you have 10 shots and then you have to reload. And finally, try adding enemy health. So make the enemy have a health bar, and when you shoot it, the health will go down, the health bar will go down, and the enemy will get destroyed once the health reaches 0. This video is sponsored by our course, Learn to Code from Zero with Godot. If you want to become a game developer but you don't have much programming experience, this course will teach you everything you need to know to make your own games. It's the only course with interactive practices that you can do right in the engine. You can find a link to the course in the description below. I really hope you enjoyed the video, and I hope you learned something. Have a great rest of your day.